Problem number 6. A block of mass m hangs from a rigid massless rod, forming an ideal pendulum. The rod is held horizontally and released from rest. What is its maximum tension during its swing? Solution for problem number 6. First, let's draw the picture. During the motion of this pendulum, we have two accelerations. One is tangential and other, which is important in this problem, is normal acceleration. Let's write the equation for this acceleration. We have mass multiplied by this normal acceleration created by tension of this rod and part of gravitational force in this direction, which is mg cosine theta. Theta is angle between vertical and this pendulum. We know what is normal acceleration in this case. That will be v square over r. And v square we can find from energy conservation. So we have kinetic energy in this point equal to change of potential energy, which is mgr multiplied by cosine theta. Now we can count what is v square from here and put it in this expression for acceleration, and we have normal acceleration equal to g multiplied by cosine theta. From the first equation we can find what is tension. Tension will be 3mg cosine theta, and the maximum for this tension will be when cosine equal 1. It means that the angle is 0, and we have answer D. T maximum equals 3mg. That was solution for problem number 6. Problem number 7. The following graph shows the results of measurements of two physical quantities y and x. What is the following best describes the functional dependence of y on x? Below, a and b are positive constants. Solution for problem number 7. The plot shows a linear relationship between x and logarithm y, which means that y is an exponential in x. Since y decreases as x increases, we have logarithm y equal a minus bx, and y equal a multiplied by exponent in power negative bx. That will be answer E. That was solution for problem number 7. Problem number 8. A block of mass m is placed on a wedge of mass m inclined at an angle theta to the horizontal. The coefficients of friction between the block and the wedge and the ground are high enough for both the block and the wedge to remain static. What is the magnitude of the friction force of the ground on the wedge? Solution for problem number 8. Gravity exerts a force mg downward on the block, which means that the wedge must exert a force mg upward on the block. Thus, the block exerts a force mg downward on the wedge, and gravity also exerts a force mg downward on the wedge. Since these forces have no horizontal components, no friction with the ground is necessary to keep the wedge static. This is answer E, and that was solution for problem number 8. Problem number 9. A person is holding a massless rope on which hangs a mass m, as shown at left. To pull the end of the rope with a constant upward velocity v, the person must exert a force Fv. To pull the end of the rope with a constant upward acceleration a, the person must exert a force Fa. Now the rope is wrapped around a fixed massless pulley and the mass is doubled to 2m, as shown at right. Compared to the original setup, how does the forces Fv and Fa needed to pull the end of the rope with a given upward velocity and acceleration change? In both cases, ignore friction and air resistance. Solution for problem number 9. To pull this mass m with a constant velocity, we need to exert force equal mg. To pull this mass with acceleration a, we need to use force Fa equal m multiplied by g plus a. Now let's check what happened on the right picture. Here, to pull this mass with a constant speed, we need to exert force Fv prime calculated from this equation, because now force Fv prime is applied to both ends of this rope. It means that the total force applied to mass 2m equal 2v prime, and that's equal to 2mg. And to pull this end with acceleration a, we need to pull this mass with acceleration a over 2. It means that now we have doubled force Fa prime equal 2mg plus 2m multiplied by acceleration of this mass, which is a over 2. From here we can find that Fv prime equal mg, which is equal to original force Fv, and Fa prime equal m multiplied by g plus a over 2, which is less than original Fa. So it means that the correct answer is A, and that was solution for problem number 9.